Hello all. Now we are actually going to connect all these elements in the analog elements, to be specific, to the PLC. Okay, so I'm just deleting these two things, 1 and 2, and I just need one thing, that is the meter, and another one is the IO field. So these are the two things I do have here, and I'm going to put two things, that will be one switch and then one output switch, not output switch, output light, one switch and light. And I do have one switch, one digital input and output, and two analog things that can display the analog values from the PLC, and I can connect the PLC input and output with this switch and light also. So let me explain you first. I'm going to the PLC program. Here you can see the main OB1, and I'm using a PLC program. That will be for the digital input. I'm using one input and one output for this, for input and output. See, you can see that is actually M0.0. I'm using a virtual memory, not an I0.0, because in the road screen we are using an HMI connection, and this switch cannot activate the I0.0. Let me explain why. The I0.0 is the input address, and that can be only activated or triggered through 24-volt DC input. So that we are using for the input a virtual memory, that is M0.0. And Q0.0 I am using because I just want to display the value only. I don't want to write inside, or I don't have the authority to manipulate the values. It's for the reading purpose only. So M0 and Q0, that is for the switch and light. And now we have one more thing, one increment and decrement block. I just have one addition block and a subtraction block. So what these blocks do, which is MW2, there is an input 1 that will be added with 1 and stores in the MW2 itself. That means that will increment 0 to 1, 2, 3, 4, 5, 6, 7 and going good. And here is the subtraction. The same memory MW2 is subtracted by 1 when it and stores in the MW2 itself. That means that will go up and down like this. I can show you that picture or the preview how it is actually working. So this is the MW2 memory, MW2, and this looks like 0 to some values, again down. See, this is a triangular waveform or something like that. Or considering the meter that goes to this position clockwise and anti-clockwise, like things, if it is a meter. Okay, so whatever, I'm not going through how it is working. Let me explain you. There is actually this addition block is working in the basis of, you can see in the two other rungs we have two comparison blocks. If MW2 goes above, that is a greater than comparison block, above 999, that means if the MW2 value goes above 99 means 1000. If it is above 1000, the M01, another virtual memory, will be set. That is a set contact, not the output coil, it's a set coil. M01 will be set. That means that will latch, and that will deactivate the addition that's in the NC contact. M01 will be latched. That means that addition will not longer be working. And there comes with the subtraction. When it is reaches the 1000, M01 will be activated, and that will be subtracting one by one. And now we get the subtraction block. And when it is subtracting and keeps going and reaches below 1, that means this contact, you can see this is the less than comparison. The symbol you can see is less than and greater than. So when it is dropping below 1, the MW2 value drops below 1, that M01 will be resets. That is a set and reset. When it is again resets, the subtraction will no longer working, M01 will be gone, subtraction will not be working, and there goes with the addition again. So that will go up, down. So let me show you. Go through online by this PLC program, and 1 second. So now we are on online mode, and you can see the simulation window right here. It goes up, 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 above 1000, nearly 1000. That means 1000, and then it will decrement when it goes touches 1000, and then it will decrementing to 0. Then again that goes up to 1000, then goes down to 0, up to 1000, down to 0, like that. That will oscillate. So these values in the MW2 we can fetch to the HMI screen. That means any process value inside the PLC. It's a bit fancier if I am showing this. Okay, that's why I'm choose this, the increment and decrement. So any process value you can choose from this. So I'm not in the online mode anymore. I'm going offline, and I'm going to root screen right here. So here I'm going to use the PLC tags. I'm going to the properties, and I like the dark theme, styles and design dark, and going to general, and the tag I have to use, which will be from here. The tag for the input switch will not be in the HMI tags. That should be inside the PLC tags. See, these are the PLC tags. Here I can choose the PLC tag. Inside the default tag table, you can see there is a couple of tables right there, and see, these are the tags inside the PLC. If you want to see the tags inside the PLC, you can go and see the PLC tags right here. Show all tags, and you can see the PLC tags. So these are the tags. M0.0, these are the tags. So I'm deleting these tags. I0.0 right here, and Q0.0 is actually motor. You can see on the main that is actually motor. Okay, so inside the PLC tag, actually I just named it previously, so that's why. So I don't need the stop, and you can see M0.0, that's tag 1, and MW0 is no longer required. We need M0, Q0 and MW2. These are the tags we are using inside the PLC program. You can see M0, M1, Q0 and the MW2. So we can go to the root screen again and configure the button. So this switch will be activated by the PLC tag M0. So I can choose the M0 as the input tag. See, M0, the PLC address is %M0.0 in the HMI screen. So we can control the switch using the PLC tag. And I'm going to the next thing, that will be the light or the motor. For the controlling the motor, I'm going to the animations, appearance. I'm going to make it dynamic using the PLC tag Q0. See, when Q0 is activated, 0 and 1. When Q0 is activated, unactivated, that will be red. When motor is activated, that will be green, like the previous times. So that's it, and I'm going to show the present display values right here. The increment and decrement percentage display value in the IO field. I'm going to the properties. Here you can see the properties, general. Inside this I'm using a tag, not SL. I'm using the PLC tags. I'm using the PLC tags. Inside the PLC tag I'm using the MW2 for displaying the current values. MW2, and for this also, for this meter also, I'm using the MW2. Where is it? MW2. Okay, so here we can, the values are actually not simulated in this HMI screen. It's actually coming from the PLC side. So before going to online, I can go to the PLC one, the hardware configuration right here, and you can see this is the hardware configuration, and you can change it to PLC or HMI view. You can see both of them, PLC or HMI. You can see the both of the inputs or the devices in the topology view. Inside the topology view, you can connect this PLC and HMI like I mentioned previously using this Profinet or Ethernet. So that's it. We can go to the root screen, and I'm going to runtime. We're actually in the simulation. See, the values are actually running. The PLC is actually running. See, and I'm going to the root screen. I'm going to simulate this and start the simulation. and there comes with the output. So we can wait for 1, 2, 3 seconds. Okay, see, now we are actually watching the values. We can see the values. Actually, this meter only consists of 0 to 100. That's the problem that I have done. So let's rectify that also. For making that error gone, I am going to use the properties of this meter. In the general, I can go here. Here you can see the maximum will be 1000. So 0 to 1000, and you can see the meter is a bit weird because of the scales. So I just want to the process tag, the scale gradient will be 100. So you can see the meter is now clear. 0, 100, 200 and up to 1000. So again I'm using the same tag. I just accidentally deletes this process tag. So I'm using the same tag, the MW2. Sorry about that. And we can go hit the simulation again. And we can wait for the simulations to start. Compile. No errors. Everything is clear. Simulation has started. And here we have it. Here we have it, and you can see the values are increasing and decreasing from the values from the points to points. See, its values are actually coming from the PLC. The process values are actually coming from the PLC. It ramps up to 1000 and ramps down to 0. Again ramps up to 1000, ramps down to 0. That is happening in every 100 milliseconds or nearly that time. So that's the use of the PLC and the HMI connection. And if you turn on the input right here, see, that will turn green. That means the input M0 is controlling the output Q0. If you want to see that things in the split screen, I am using the simulation also right here. And you can see, no, sorry, you can see the values right here. See, 700, 700. The same values are acquired by the HMI or the SCADA. And if you turn on the not IB0, not the input bit 0, the M0.0, MB0, MB0, that is used for making the bits on. So that is here you can see the M0.0. This is the switch right here. I'm using the switch. I'm using the switch here. Click on. See, the PLC can control the switch and the output. Switch and the output. If you want to see the output 0, QB0 I call it. Deleting this stuff and insert an output variable. If I turns on the MB0, we get the QB0 and inside the HMI also. And the values also. The same values I am getting over here for the real time. That is the HMI and PLC connection. So you can acquire any value from the PLC to this HMI, or you can control the PLC tags using the HMI virtual memory. That is the PLC HMI connection. So thank you. So in the next videos, we will be exploring too much about these things. Next.